Hello there. Hello again. I just thought, since we're on the subject of corrections and addendums and corrections to addendums and so on and the like, I would like to make one correction to the last addendum wherein I explain well, it's not going to be there anymore. It's nearly there. This business about maintaining an error code in a variable. Now, I was going to make a quick video to make this correction, but I wanted to make sure that I understood how the system for making this correction works, because it's one of those weirdo things that has to do with multiple threads. Anything to do with threads is kind of funny. Now, so supposing some kind of error occurs, like this buffer here is too small. Where's the size? The size is blah 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 here. So suppose this is too small. In fact, I'm checking for that now. And I should be setting some sort of error code somewhere. Now, the error codes that were described in the help or get open file name. Yeah, that's the one. Yeah, these are returned by calling this function. Now, in this case, I don't think that there's too much to worry about. These values, whatever they are, I think they were all word values, turned out. Yeah, they're all less than 65536. In fact, they all seem to be less than 5,000 hex. P, T, C, E. Use some CDs, some FNs, and that's it. So, and not CC error. So even less than 3,000. So for instance, a totally invalid one, if I wanted to use a D word, suppose I'll just declare a D word value up here. And find that. To be that. So that's out of the range of error codes. So once if somebody called this function retrieve a value, if the error code, last error code is not equal to the invalid one, then I would return it and set it to the invalid code. Now that will seem to work fine, except, well, as I said, it doesn't matter so much in this case, because it's not very likely that you're going to have two different threads running an open or save dialog box. Although it is possible you could perhaps have two modeless ones going. That is, maybe one box is maybe you got two open boxes for two different threads, and you have to combine two files. I don't know. Now, if one of them makes an error, I want to make sure that when I set this error code, it's going to be associated with the thread wherein the error occurred. Now, there's a way to do that, and it's a natural, it's one of the most basic, most fundamental attributes of the operating system, that every thread gets a little storage area for storing data specific to that thread. And the way you do that is using something called thread local storage, TLS. Okay, thread local storage, and the first function that you would call is this TlsAlloc. Okay, now that returns you a single number. Okay, and there are only so many indices that are available. I think the maximum value is quite small, like 64 or something. But it doesn't matter, because it turns out that you use the same index for every thread. You just need to call this once, and you always use the same index in the same module to set or get your data from your slot. Now your slot is the size of one pointer. So for instance, to set a value, you pass in the index and a pointer. Okay. Now, depending on what thread happens to be running this function, that pointer will go to somewhere in the thread's internal data area. Okay. Now, the data itself could be any kind of data from malloc or whatever. A good thing to put in might be a linked list or something, right? Then you can just grow it as big as you want. Just keep adding more and more stuff starting from the same pointer. Now, here is the code they show you for using thread local storage in a DLL, like we have in our case. On process attached, we simply call TlsAlloc and hope that we don't run out of indices, and we probably won't. Okay, now what they have here, you see this DLL main. I think I have it. I'm using the CRT DLL main, which is a similar interface. There are 4 possible reasons for this function to be called. One is the module attachment, so the exe loads up DLL. That would be the point where you would call this, the one and only time that you would ever call this through the duration of the program. The returned index you can save off as a global variable. So instead of saving an error code, I would save an index value. Now, if a thread uses a function in the library, this same DLL main will be called once for that thread to indicate that a particular thread is making use of the library. So that gives you a chance, would give you a chance to set some data using the index into your thread local storage area. On detach, well, you don't need to release the index, but you may want to free the data that you allocated. Here, some data was allocated using local-alloc. You could use malloc, doesn't matter. And when that thread, however, it figures out that the thread detaches, then you can free it. When the process finally exits and the library is unloaded, you can free that index. I don't know if this is really necessary. Yes, I guess it is necessary because the library could be unloaded and then loaded again. And so you don't want to run out of indices. So you should free it up. Now I wanted to give this a try in a different project back where we were. And I do use that function for my thread class that you've never seen, because threading is complicated, and a lot of explaining has to be done to get it right. Now, I added an extra thing here just to mix things up. What this thread class has and stores in its thread local storage area is a single value boolean called delete self, and that is that this thread is when the thread proc exits, it checks to see if this flag is set, and if it is set, then it deletes itself. So it's like auto-deleting object. And then let's wrap in some functions, set delete self, and the thread procedure is, I added that, is here. Now, this function, when this function is running, the current thread is the thread in question. So you would want to set thread locals data in this while this code is executing. In fact, I do set it here. Okay, you would not set it in the constructor because the constructor is called can be called by any thread. In fact, definitely not this thread. It hasn't started yet, and so setting the thread local data at that point would be useless. I want to check what this means. It might be an error. Well, this is during the destruction. Okay, that's something else. Okay, so what I did was I added a string and I created a struct and say with pointer to the struct. Now the one thing you might think would be a smart idea would be to save a pointer to this thread object. But that's no use if this thing gets deleted, for instance. You have it in your thread's local storage, you have a deleted pointer and it's of little use to you. What you want to put in your thread local storage is global data that is sort of property of the thread itself and not necessarily of this structure. So first, I did create a member just so I could hang on to the data long enough to wait for the thread to start. When the thread starts, this gets called and stub 1 gets entered. At this point, we're now in the thread. Now I have created a function called SetValue. And let's see, because of the way these things go, you have to be very, very careful. First off, we want to make sure that we've got an index, right? Now, it's possible that somebody could declare a static thread object, right? And in its constructor, maybe start a thread going or something. And it's possible to have a thread already running without having allocated this index yet. And so to protect against that, I'm using something called something like what people call a singleton. That is, I want to be able to check a value and make sure that that once it's set, it remains set and doesn't get unset by the operating system or something like that. One way to do that is malloc, but instead what I did was I created a static, it's global, but if I can put the word static in front here. Global variable TLS manager. This is to manage a single number. And this object contains a static D-word member, which is that index. When the module gets loaded, the order in which things are constructed happens from top to bottom. So it goes along, like for instance, this will get set to null first. Now it's going to try to initialize this thing. TlsMan, and in its constructor, it calls init, which sets the index to TlsAlloc. So in order for the compiler, or whatever, the runtime library, to build this structure, it has to invoke this constructor, which has to call this init, which has to call this TlsAlloc. And so by the time we get to this line, this should not be equal to -1 anymore. If you reverse these, and I have it, it's possible to have in the constructor here to have it's possible for someone to reference this object and try to get the value, and we'll find that this value is equal to -1 because the object hasn't been constructed yet. But this seems to fix it, and it doesn't matter, I'm checking anyway. Whenever it's -1 in it. Now I've talked a long time on one of the crucial problems of programming, which is everybody wants to get in first. And I want to make sure that index is available. Once it is available, you never need to make a new one. I can set the data that I have here. Whoops. Oh, there's two of these. One has exception handling and one doesn't. Either way, I have this asserted. It doesn't fire anymore. And I'm making a double use of this. If what's passed in is null, then I retrieve the pointer, the thread local data storage pointer, and set that value to null after deleting it. Otherwise, I set the value to the data. And the data is malloc, I believe, right here, yeah. Now it's malloc in one thread, deleted in another thread. I don't think that matters. It doesn't seem to matter. Now I wanted to prove to myself that it's actually using this. And I do have this drawing program. And what I did was, in the DLLs here, first I allowed for a thread to have a name, and that's what I'm storing in its thread local storage area. And every now and again, okay, I'm going to debug load. Every now and again, I'm going to trace out what I call thread name. This should change color eventually. Now the code for thread name is the same for every single thread. It uses the same number, calls the same function to retrieve the same value. And that's why multi-threading is strange. Okay, how do I get this thread name? I declare a string, and I call this function, which retrieves the one and only TLS index value, gets the data, copies the name. Okay. Now that function is being called from within the thread procedure. If I called this same function from a different thread, even in using the same class, I won't get the same value. For instance, somebody could call spawn thread. In fact, that gets called every now and again. Now, after allocating this random dot, I could print out if it is public, let's get name public. Protected, but anything that's protected can be made public. Okay, now anyone can call that function. Now let's see what happens. Now, oops, I want to be in a random dot. Not you. Random dots. Suppose someone wants to add some random dots. I could say h dot right? Get thread name. Now that's also going to be called from within the thread. So let's see what happens. I don't know, it might crash or something. Hope not. Right. It failed. Data came back as null. Because it hasn't been set yet. What I want to do, I want to call after, I want to call that after the thread starts. I spawn that thread. See what happens. After this point, it will have allocated its thread local storage. Now, again, I have a problem. You see, although the storage area has been allocated, the thread that's making this call is when main startup, not the docs thing. So that is invalid. That's an invalid function call. Even though, you know, this function exists and it works, it can only be called from the thread wherein it's valid. When we undo that, everything done. I'll just show you that you get different numbers. Now I'm just printing these out randomly within the thread prompt. Okay, there's only one thread at the moment. Well, there's three. So sometimes I'll get ones and zeros. Because there are two going on. To be very lucky and getting only ones. Now there are three, so there are two here sometimes. Okay. Now, where is that happening? That's a great point here. So to get the thread name, I'm creating a string. I get my index, which happens to have always been 26. And now I'm calling this get TLS data. Again, more assertions. TLS get value from index. Okay, now this is the same call and the same index and everything for all of those threads. However, depending on which thread it is, it's making the call. I might get a different value. So that's thread local storage. Now, how do you clean it up? One thing you can't do, for instance, would be to clean it up in the destructor. Because anyone could call delete on one of these objects from within any thread. Okay? So what you want to do is remove that data before the thread exits, and that's what I'm doing here. And here. Here are two cases. This is set up one traps exceptions and one doesn't. Oh no, sorry. I don't need to do it in this one because this one calls that one. Setting it to null to freeze the data. And that's thread local storage. Now, that was only called once. Right? I'm not using up, as more and more threads are being added, I'm not using up more and more of those indices. In fact, it's always the same index for all of the threads. But the data contained at that same index and via the same function is different depending on which thread is being executed at the time of the call, or is running at the time of the call. Now for the error message thing, going back to our problem, it's not such a problem here because we're not likely to have many threads competing for this error code. But I should do as it says in the help. Allocate a thread local storage index. Luckily, it's all I have is a dword value, so I could just set that directly. No allocating memory. I don't need to do anything on thread attach or thread detach because I'm not allocating any memory. And when I store the error code, I would call TLS SetValue to the error code, and to retrieve it, get value. Now there might be an error for one thread. One thread calls this function, and there's an error. It's set. Another thread calls this function to retrieve the error. Doesn't get any error because it's not the right thread. But if the thread where the error occurred calls this function, it will retrieve the correct value. And that's a very long addendum, and whatever. It's something you have to know about when dealing with multiple threads. Things like global variables don't make sense in the world of multi-threading. Different threads call the same functions, and so they have, it's often, especially with error codes, those error codes are specific to the given thread in which the error occurred and can't be saved as some sort of global variable. And that's why TlsAlloc and TlsFree and getValue were created so that you could use a single number, an index, that's the same value for every single thread, and the interfaces to access the data is exactly the same for every thread. And so you can treat that as a type of global variable. But it is automatically specific, unglobalized in terms of threads. Global in the sense that it's the same value, same index for every single thread. Not global in that that index corresponds to different data depending on which thread is accessing the data. Okay, spoke too long. See you.